Hello everyone, welcome to FAANG tastic solution. So today we are going to solve a Leetcode medium problem, which is basically says count the square submatrices with all ones. And this question again been asked in Google and Microsoft Amazon. So it says given a m cross n matrix, so we'll have given a matrix with all mixes of ones and zeros. Some places it will have one and some places at zero. Now we need to return how many square submatrices have all the ones. So how many square submatrices have all the ones? That's what we need to give. So if you see the very first example, let's see the second, which is the smaller example. So all the square, let's say these numbers at which all places have one number that again is the submatrix of length 1, 1, right? So if you see, we have 1, 2, 3, 4, 5, 6, 6 square of side 1. And then if you see, does this 2 cross 2 matrix have all ones? No, we don't have here, 1. This is again a 0. What about this one? This is again not a solution. What about this one? So yes, we have one matrix of 2 cross 2. What about this one? No, this is again not an answer. So that's why we got into the answer 1 square of side 2. What about the 3 cross 3? Again, not an answer because we have this and this, these three, 0. That's why we only have 1 cross 1 and 2 cross 2 matrix, 6 1 cross 1 and 1, of side 2. And same goes for here. We have around 10 1 cross 1 matrix. And what about the square of square submatrix? What about the 2 cross 2? We'll have this one. We'll have 2. We'll have 3. And we'll have 4. That's why we have 4 square of side 2. What about 3 cross 3? Can we form this? Answer would be yes. So we can see 10 1 cross 1 square, 4 of side 2 and 1 of side 3. So it's total coming to 15. So let's see how we can solve this, or we'll see what can we do it here. So we have this example, and now we'll see. Let's start. If we're going to solve, with our loop, like we need to read, each numbers one by one. So if you're at this very first level, do we know like does this form number a square or not? So yes, this form a square of 1 cross 1, right? That we know for sure. What about the 2 cross 2? Can this form? So we can again start a for loop inside for loop and see can this form a loop, right? So yeah, we can see yes, this can form a 2 cross 2 as well. And we can go ahead and see, this will be definitely belonging to 3 cross 3 as well, right? But this will have more complexity now because if you see this, how we are saying that this will belong to 1 cross 1, then again from here again just go ahead and see can this belong to 2 cross 2? Yes. And then again see can this belong to 3 cross 3? Answer would be yes. So again inside the loop, we have to again iterate at each places, iterate a number of times. But can we optimize this? Because let's say if we're at this place, we don't know the future numbers. So can we know that, if we are at this place, how many square can we like this belongs to? Like can this belong to 1, 1, 2, 2? So can that solve a problem? So let us see if that can solve. So for this, like the total number of squares are total 15, right? So let's try to see if we can reach to this 15 solution. So first we'll be starting the first row. So if I'm at this location, right, I know that this can only belong to 1, 1, right? That's the only thing I can know if I'm at this place. Even though this belongs to 2 cross 2, I don't know the future numbers. So that's the like let's replace the same matrix those numbers, like how many square this belongs to. What about this one? So this will again belong to 1 cross 1. This one again belong to 1 cross 1. Even though this belong to 2 cross 2, but I don't know these futures numbers. I haven't read them. Same will go with this first column as well. If I'm into the first column, I know that this will definitely belong to 1 cross 1, but can this belong to 2 cross 2? I haven't read this number yet. So that's why I'm not sure. Same will be the case of this place as well. I know that this belongs to 1 cross 1, but does this belong to 2 cross 2? I don't know. I haven't read this number yet, right? If I came here, I haven't read this number yet. So that's why I'll be updating the first column, with 1, that they can belong to, 1 cross 1. What about if I'm at this place, right? So if this value is already itself a 1, then we know that this belongs to a 1 cross 1 matrix because this number itself is a 1. But does this number belong to 2 cross 2 matrix or not? So we have already reached these numbers, right? So I can just go ahead and see these previous values. If they all are 1, right? 1, then I know, yep, this can belong to a 2 cross 2 matrix as well. So I can just add answer in 1 plus 1, 2, right? Then can this belong to 3 cross 3? Answer is no, right? Currently, this doesn't belong to 3 cross 3. Then how we are saying that this doesn't belong to 3 cross 3? Answer would be no, we are just dependent on these three values, right? If we are at this place, we know these three values. So we just added 1 because this belongs to a 1 cross 1 matrix because this number itself is a 1. And the second number we added 1 based off these three values. So we didn't add all these three values. We just kept only one of the values of, these three. That's what we did. And will be pretty clear when we reach to this place. So just wait for this one, like understand this problem. If you're able to understand this one, then we are able to solve it, or even this number. So let's try to solve this number as well. So let's see for this number first. What will the answer? If we are at this place, this number was already 1, right? So this definitely belongs to 1 cross 1 matrix. Does this belong to 2 cross 2 matrix as well or not? So this does belong to 2 cross 2 matrix if we see, right? But how can we come with the solution? We are again going to read the same, these three values, the way we read for this particular place, these previous three values. So we will see what is the number we have. We have 1 comma 1 comma 2, but our final answer is going to be 2, right? So we have to add only 1. So we are, instead of all these three 2, like three values 1 and 2, we are just going to pick one number, right? So we are just picking 1, which is basically, if we say, the good way to say, the minimum of these three values. So 1 comma 1 comma 2, the minimum would be always 1, either this or this, right? So we just pick the minimum of these three values, and that's why here if you see, our solution came as 2. So this place also belong to 2, so we are good. What about this place? So this will again belong to 1 because this number is already 1, so this will belong to 1 cross 1 matrix. But can we going to add, like, does this belong to 2 cross 2 matrix? So we just need to look these three numbers, right? And if we see, the numbers are 1 comma 1 comma 2, and we know that this belongs to 2 cross 2. So this will be the minimum of these three numbers, whatever. So that will be 1 only, right? So our answer is 2, and our answer is not 3, right? Because we know that this doesn't belong to a 3 cross 3 square, right? Because this will be this will be a rectangle, not a square, right? So that's why we know that answer is 3. But what about this place? So this place, like if you're at this place, we know that this belongs to a 3 cross 3 matrix, right? How do we do that? How do we know that? So we know that this number itself is a 1. So answer would be 1 because it's a 1 cross 1 matrix. And now let's go ahead and see these three values. So these three values are nothing but 2 cross 2 cross 2, right? So minimum of 2 cross 2, 2 comma 2 comma 2 would be 2 only. So that's why the number would be 3. So this belongs to 1 cross 1, 2 cross 2, and 3 cross 3 as well. So that's right. The total number, like total number of square it belongs to would be 3. So number is 3. What about this place? Does this number belong to 1 cross 1 matrix? Answer is 1 because it's already 1. So answer is 1, right? Does it belong to 2? We know that it doesn't belong to 2 cross 2, 3 cross 3. We know that answer would be 1 only. But let us see, cross verify again with these three numbers. So it would be 0, 2, 3. So minimum of 0, 2, 3 is 0. So 1 plus 0 is nothing but 1. So that's how we came to the solution. So at every place, if we are into the first and first column, we can just initialize them with the 1 if the values are 1. Otherwise, we are going to keep 1, whatever the current number we are at in the current index, that is 1, plus minimum of the previous three values, then we know that our solution is there. And if we try to sum all these numbers, now the answer would be, if you see the 15. So 1, 2, 3, 4, 5, 5 to 7, 7 to 9, 9 to 11, 11, 3, 14 plus 1, 15. So we reached our solution 15. So that's what we just needed it. So now we can pretty easily code this. So let's go ahead and see how we can do that. So we just need one variable, let total squares, let's initialize with 0, and let iterate our matrix now. I should be less than matrix.length I plus plus for let j equals to 0, j should be less than matrix I of I dot length, comma j plus plus. Now let's try to fill the first row and first column, like these three values. This value, try to sum them, and these two values, right? So what we'll do, we'll say if I equals to 0 and matrix of I comma j, right? So that means we are into the first row. For this one, we are into the first row and those numbers are 1. If that's the case, then just go ahead and update, our total number of square plus equals to 1. And you can see we have also updated our matrix of I comma j at each place, but here we don't need to do that into first and first column, because that numbers are already 1 only, right? So here we don't need to update them. And similarly for the first column as well. So if j equals to 0, like we are into the first column and matrix of I comma j, and we don't need to include this one because we have already added this into total square when I was 0, right? So when j equals to 0 and I not equals to 0 and matrix of I comma j, then total square is equal to total square plus 1, right? So now we are good with this first row and first column, right? Now let's go ahead with the non first and first column, right? So we can do if I not equals to 0 and j not equals to 0 and matrix of ij, right? That's the only condition we have now left. If this is the condition, then what we are saying, so what we are saying, like we're first updating our matrix value, if you see with these three numbers, right? So we are saying matrix of I comma j equals to matrix of I comma j plus math dot min matrix of I comma j minus 1 comma matrix of I minus 1 comma j comma matrix of I minus 1 j minus 1. So whatever the minimum values are there, we are just going to add it, and then in total square we just added all the numbers, right? These numbers to get our total numbers. So we are just going to add these two into our final solution, these three into our final solution, right? Total square plus equals to matrix of ij. And once we are done, let's just return this, total square. Let's try to run it. Cool, just got accepted. Let's try to submit it. Yep, solution got accepted. So I know like this can be implemented, these three many loops, but that's easier way to understand and solve it. Like you can just write into one, like I and j is there, and this total square you can move somewhere else. That's how we have to do it. So that's it for today.